Identifying quadratic functions goes like this. Identifying quadratic functions go like this. When you look at an equation, your objective is to identify whether the quadratic function is there, whether you are using a graph table or an equation, and then your job is to determine whether they have a minimum or maximum value, or to graph a quadratic function and give its domain and range. When you look to find a graph its quadratic function, you would have a number squared such as x squared. An example of an equation is y equals x squared. If you graphed it, it would appear to be a parabola. Just remember that the quadratic function is any function that can be written in standard form. Just remember that the quadratic function is any function that can be written in standard form of y equals ax squared plus b plus bx plus c. Remember that the a, b, and c are real numbers. Previously, you identified the function of a quadratic function by finding the constant change in corresponded to a constant change in y. The differences between the y value for a constant change in x values are called the differences. Okay, so now since there is a given table, you can see that the first ordered pair with a constant change in x values. See if the second differences are constant. Find the first constant difference. Then you find the second difference, and then you're left to see it's a constant. You have a quadratic function. Now finding if an equation is quadratic, you are given an equation y equals ax squared plus bx plus c. When you have an equation such as y equals negative 3x plus 20, first you would see that there is no a, and that makes the value of a 0. So this is not a quadratic function. So this is not a quadratic function. In this other equation, to see if the quadratic y plus 3x squared equals negative 4, now you will try to see if the function is written in the form y equals ax squared plus bx plus c. To solve for y, you will subtract the 3x squared from both sides. It is a quadratic function because it can be written in the quadratic form where a equals 3, b equals 0, and c equals 4. It's a quadratic function because it can be written in the quadratic form. It's a quadratic function because it can be written in the quadratic form. The highest point on a parabola is the vertex. If the parabola opens upward, the vertex is the lowest point. If the parabola opens downwards, the vertex is the highest point. If a is greater than 0, the parabola opens upwards, and the y value of the vertex is minimum value of the function. On the graph that you can see that the bottom point of the pair is negative 3, 0, and the vertex is negative 3, 0, and the minimum value is 0. If a is less than 0, the parabola opens downwards, and the y value of the vertex is the maximum value of the function. In the graph that you see, the vertex is 3, 5, and the maximum value is 5. Unless the specific domain is given, you can assume the domain of the quadratic function is all real numbers. You can find the range of a quadratic function by looking at its graph. For the graph of y equals x squared minus 4x plus 5, the range begins at the minimum value of the function where y equals 1. All the y values of the function are greater than or equal to 1, so the range of y is greater or equal to 1. Identifying quadratic functions goes like this. Identifying quadratic functions go like this. When you look at an equation, your objective is to identify whether the quadratic function is there, whether it's a graph, table, or an equation.